So we have the primary trigonomic ratios, which we know as SOHCAHTOA. So remember, SOHCAHTOA can only be used for right angle triangles, which we often denote with a little square to denote a 90-degree angle. So just a little self-check. Would we use SOHCAHTOA here? So let's see. With the first triangle, yes, because we have that 90-degree little square in the corner. The triangle 2, no, this is not a right angle triangle, so no, we would not use SOHCAHTOA here. For the third one, it's a right angle triangle because we have a little square in the corner, so yes, it is a 90-degree angle, so we can use SOHCAHTOA. So remember, SO stands for sine, which is always opposite of hypotenuse. Read through the slides. Cosine, the ka, is always cosine, which is adjacent over hypotenuse. And then we have tangent, which is opposite over adjacent. Okay, so we just reviewed the slideshow, which I posted on grade 10 trigonometry, and the trigonomic ratios which we had learnt was sine, cosine, and tangent, which we use the acronym SOHCAHTOA. So exercise number 1, we are going to use the primary trigonomic ratios to find the missing angle. So I know this is a 90-degree angle because of the little square here. So I know I can either use sine, cosine, or tangent. So I'm going to write that out, and we'll figure out, based on what we have, what we should use. So I've run into a little bit of a problem because I don't know, based on my angle, if what I'm looking at is hypotenuse, adjacent, or opposite. Let's find that out together. So always opposite of my 90-degree angle is my hypotenuse. So I'll label that as hypotenuse. Then, from my angle in question, from my theta, what's opposite from that angle will be my opposite. And then adjacent is another word for beside. So I know that the 10.4 units will be adjacent to my theta. So based upon what I have opposite and I have adjacent, which makes the most sense to use tangent. So I'm going to plug in what I have. Tangent of theta equals, I know tangent is always opposite over adjacent. So I'm plug in what I have. My opposite, is 17 over 10.4. And then I know my tan theta is equal to 17 over 10.4. And then to isolate my theta, I would do the inverse of tangent, which is inverse tan. 17 over 10.4. I'm going to plug that into my calculator. So I have inverse tangent of 17 divided by 10.4, make sure it's in degrees, and I can see that. So my answer, I'm going to round to the nearest whole number. For angles, you always want the nearest whole number. That's going to be rounded to 59 degrees. And did I find what I was asking for? So I was asking for an angle, so yes, I am done. Therefore, theta is 59 degrees. So then we have find the missing side length. So again, same thing, we're going to use SOHCAHTOA to determine which primary trig ratio we would use. So let's see. From the 90-degree angle, what's opposite 90-degree angle is my hypotenuse. And then from my other angle in question that isn't my 90-degree angle, that will be what we consider our opposite side length. And then adjacent just is another word for beside. So based upon what I have hypotenuse and I have adjacent. So it make the most sense to use cosine law. Not cosine law, cos. Cos theta equals adjacent over hypotenuse. Let me plug in what I know. I know cos 52 degrees equals, my adjacent we're denoting as x. My hypotenuse we're denoting as 16 centimeters, but I'll write 16. Then let's take up my calculator and let's see what we get. So cos 52 degrees. So to isolate for x, I want x by itself, so we can do that by multiplying 16 on both sides, which essentially means that I am putting into my calculator 16 times cos 52, which I'm sure if you can see that. My x value, which will round to the nearest tenth, will be roughly 9.9. Since we were using the measurement of centimeters, therefore my missing side length is 9.9 centimeters. Okay, so hopefully you remember how to use the primary trig ratio, SOHCAHTOA, which you learned in grade 10. Now, in grade 11, new math concept unlocked. These are called the reciprocal ratios, which cosecant, which I will write phonetically, cosecant. Cosecant is simply hypotenuse, Cosecant is hypotenuse over opposite. Secant, which I'll also write phonetically. Secant is hypotenuse over adjacent, and then we have cotangent, which is simply adjacent over opposite. Now, one question you may be asking yourselves, I wonder why they're called the reciprocal ratios. My answer to this is they are simply the reciprocal, which we know that fancy math word means a flip. They are simply the reciprocal of the primary trig ratios. So, for instance, cosecant, which is hypotenuse over opposite, we know is literally just the reciprocal of sine, which sine, as we had just talked about, sine is equal to opposite over hypotenuse, and cosecant is hypotenuse over opposite. Then secant is simply the reciprocal of cosine, because secant is hypotenuse over adjacent, which is basically the flip of cosine, and cosine is adjacent over hypotenuse. Then the last reciprocal ratio is cotangent, which is adjacent over opposite, which is literally just the reciprocal of tangent, and tangent is opposite over adjacent. Okay, so now for this next example, I want you to calculate the reciprocal ratios of the following triangle. So I'll give you time to do that. I'll probably put like a 5-minute timer on. So we'll calculate the reciprocal ratios of the following triangles. So cosecant is simply, as you remember, the reciprocal of sine. So I know cosecant is hypotenuse over opposite. So based upon my angle in question, my opposite is 3 meters. My hypotenuse, which is opposite of a 90-degree angle, is 3.5, so then 1.8 would be my adjacent. So hypotenuse 3.5, opposite would be 3. I'll need to calculate that in a moment. I'll save it. Secant is simply the inverse of cosine, which would make it hypotenuse over adjacent, which would make it 3.5 over 1.8. And the last one, it's just the reciprocal of tangent. Cotangent is the reciprocal of tangent, which I know TOA. So then the opposite of opposite over adjacent would be adjacent over opposite, which would make it 1.8 divided by 3. So I'll get out my handy dandy calculator and I will calculate that. So I have 3.5 divided by 3, which gives me 7 over 6. 3.5 divided by 1.8 gives me 35 over 18. And last one, 1.8 divided by 3 gives me 3 over 5. I'm just going to make them all the same color. Obviously, you don't need to do this. I just love my colors. Amazing. So, have we calculated the reciprocal ratios of the following triangles? Yes, we have. Amazing. Now, new math topic unlocked, special triangles. So, there are two main special triangles, and the reason why we call them special triangles is when we have right angled triangles with these specific angles, we automatically know the side lengths. But since you all don't know the side lengths of these special triangles, let's go through an investigation right now. So, step 1, divide the square into two right triangles by drawing a diagonal. Diagonal. So I'm going to draw a diagonal. Okay, so because it's a square, I know that I've made two right angle triangles. And because I had just said that right angle triangles are denoted as right angle triangles by having the little 90-degree little square, I'm going to draw that in my corners. Okay, so very interesting. So, since we originally had a square, I know that all of my corners in all angles in a square are 90 degrees. Well, I split this perfectly in half. Well, just imagine I split perfectly in half. But perfectly in half, that means that both of these angles will be equally split into two parts. Well, it will basically be 90 degrees split equally into two parts, which gives me 45 degrees. So I know that I now have a triangle in the upper right-hand corner that's 45 degrees, 90 degrees, and the other one will also be 45 degrees since, as I said, I'm splitting 90 degrees. That originally was my angle of the square, and I'm splitting it perfectly in half. And I know 90 degrees divided by 2 is 45 degrees. But that also means that my other triangles, so the lower half of my triangles, I've also created a 45-degree, 90-degree, and another 45-degree. Okay, so I have essentially created two triangles. And based upon my measurement, I know both legs of my triangle are each 1 unit in length. The only thing I don't know is the hypotenuse. That's the only thing I don't know. But since these are basically the exact same triangle, all I need to do is calculate the hypotenuse once, and I will have the full measurements of both triangles. So then we'll say it's 1 unit, 1 unit. Okay, so how would I figure out my hypotenuse? Hopefully you're all thinking Pythagorean theorem, which remember is a squared plus b squared equals c squared. So that means 1 squared plus 1 squared equals c squared. 1 squared plus 1 squared, 1 plus 1, because I know 1 squared is 1, 1 squared is also 1. How about I highlight that so you know where I'm getting those numbers from? Then I know that 1 plus 1 gives me 2. But the thing is, I want to know just my hypotenuse. I don't want to know the squared length of my hypotenuse. So I'm going to square root both sides. So then I know that the hypotenuse of my triangle is actually root 2. So I'm going to put that on my square. This is sorry, not 1 unit. It is root 2 units. Amazing. Okay, now let's see. We did step 1. Divided the square into two right triangles. Yup. Label all angles and side lengths. Oh, let me show you what I know on my little triangle. 45, 45. Amazing. I have labeled everything I need to know, and I know that these side lengths of 1 and 1 and the hypotenuse of root 2 will be the same for any triangle, any right angle triangle. Sorry, I'll clarify. Any right angle triangle that is the 90-degree, 45, 45-degree special triangle. Okay, now let's determine step 3. Let's evaluate sine 45 degrees, cos 45 degrees, and tan 45 degrees. Okay. I know sine can be made by doing opposite over hypotenuse. So maybe if this was the 45 degree I was talking about, which obviously this is an isosceles triangle, so it really doesn't matter since the legs are both the same and the angles that aren't the 90-degree angle are also both the same. So it honestly does not matter. But for simplicity purposes, I'll say the 45 I just highlighted is the angle in question. So my opposite, adjacent, and hypotenuse. So I have opposite, which is 1 root 2. The next one I have, again, I'll use that same 45-degree angle, but it honestly does not matter which angle I picked. So we have adjacent, which is also 1 over root 2. And then we have my last one, tangent, which I know is opposite over adjacent. So I know it's 1 divided by 1. So what do you notice? I notice that sine 45 degrees is the same value as cosine 45 degrees. And since these are the same, my tangent ratio will literally be 1 because it's basically a number divided by itself. Very, very fancy stuff. Very, very fancy. Okay, so give you time to process that, and we'll move on to the next special triangle. Okay, so we just unlocked the special triangle for the 45, 90 degree, 45-degree triangle. We'll do an application involving special triangles once I talk about my last special triangle. So, the next special triangle, again, we will go through an investigation, and the investigation is as follows. So, I have an equilateral triangle that I'm going to split into 2 right triangles by drawing a straight vertical line. So, on my equilateral triangle, I'm gonna make 2 right angle triangles by drawing a vertical line going down. So that's 90 degrees, and I've created another 90-degree triangle. Amazing. Okay. So I did step 1. Now, label all angles and side lengths. Hint, may need to use Pythagorean theorem to find the side lengths. Okay, so because this was originally an equilateral triangle, what do I automatically know about my angles? Okay, hopefully you remember, or maybe you didn't remember, that in equilateral triangle, all of my all of my angles are 60 degrees. I'll write that more in the middle for that one. 60 degrees, and that's 60 degrees. Amazing. But, as you just realized, we just split this equilateral triangle into 2 different triangles. So, let's see what we have. So, I would still have a 60-degree angle. Because I made it a right angle triangle, I know I have a right angle. And the only thing I don't know is my top angle. But hopefully you realize it's not too difficult to find the value of that right angle, that angle that we're missing. All we are literally doing is we are splitting 60 degrees into 2 equal parts, which will give me 30 degrees. Amazing. Okay, now, next thing I need to do is find the measures of my right angle triangle. So I have, okay, sorry, I am skipping ahead a little bit. Obviously, you now just see random numbers here. I realized I made a very brief mistake. And these are actually not 1 unit, these are 2 units. And the reason why they're 2 units is because we kind of don't want to have to deal with uh, fractional side lengths like this one right here. Doesn't look nice, so I apologize. I have to correct your note. So this is 2 units. Okay, so let me fix my side lengths on my triangle. Okay, so it is, my hypotenuse is 2 units. My base, I guess my base would be the 2 units divided by 2, since I am splitting this equilateral triangle into 2 isosceles triangles. So that means the bottom side length, will be 1 unit. And the only thing we don't know is my x value. Okay, so Pythagorean theorem, a squared plus b squared equals c squared. 1 squared plus x squared equals 2 squared. I'm just highlighting where I'm getting these numbers from so you can follow along. Okay, so then I have 1 plus x squared equals 2 times 2 gives me 4. So I have x squared equals 4 minus 1. X squared equals 3. But I only want the value of x, so I'm going to square root both sides, which gives me the square root of 3. Awesome. Okay, so we did 1, we did 2. Now we're going to evaluate sine 60, cos 60, tan 60. Tan 60. Then we're going to do the same thing for sine 30, cos 30, and tan 30. Okay, so I'll focus on the little triangle I have here. So from 60, this would be my adjacent. Sorry, 1 will be my adjacent, x will be my opposite, and 2 will be my hypotenuse. So sine is opposite over hypotenuse, so that would give me, I guess I should write down that it's actually root 3, not just x anymore. Okay, let's go back to it. So opposite, which I know is root 3, over hypotenuse 2. Then I have cos 60, which I know is adjacent, 1, over hypotenuse 2, so 1 over 2. My tangent is opposite, root 3, over adjacent, which is 1 in this case. Then we have sine 30 degrees. So now, because I'm switching the angle, hopefully you realize that that does, in fact, change my opposite and hypotenuse. So now the 1 unit is my opposite now, because my angle is now 30, and my adjacent is now the root 3. Okay, same thing. We're going to do the same thing again. Opposite, so in this case it's 1 over 2, cos 30, adjacent is root 3, over hypotenuse, which is 2, and the last one, tan 30 degrees, opposite, 1 over root 3. What do you notice? Um, Sine 60 is the same as cos 30 degrees on the special triangle. We also have cos 60 degrees is the same thing as sine 30 degrees. And my tangent are literally just reciprocals of each other. Very, very cool stuff. Okay, so now you have seen the special triangles. Here's a brief review of them. Okay, so as I promised, I will do one example of applications with special right triangles. Okay, how would we go about doing this? Well, I'm seeing my 60-degree angle right now, so I know exactly which special triangle I'm dealing with. And it is this one. Okay, so I want to find the values of x and y. So let's see. Based upon the summary of my special triangles, I know opposite to 60 degrees is root 3. So this is actually my root 3. Then I have to figure out what is my adjacent to it and what is my y value. So how would we go about doing this? Okay, so trying to figure out how this applies. So I know that with any 30, 60 degree, 90 degree triangle, opposite um, opposite to the 60 degrees is my square root 3, depending on what scale, like if I'm multiplying it by 2 or 3 or whatever, gotta figure that out. Okay, so we want to figure out how we go from 8 to root 3. I know opposite to my 30-degree angle is the side length of 1, and my hypotenuse is 2. Okay, so I want to figure out how I can go about doing this. So, one way to determine the value of 1 is to simply do 8 divided by root 3, which, since a good thing we talked about rationalizing denominators, since we don't like having a square root sign in don't have a square root sign in the denominator, so we're going to multiply both of them by root 3, root 3. This gives me 8 root 3 over 3, which will actually be the value of this value, of my x, sorry. 8 root 3 over 3. And I know once I found my x, all I have to do is multiply my x by 2. So that means that my y value is simply 16 root 3 over 3. I also realized that I should have given you this special triangle because it's probably a lot. So I'm going to find another one that hopefully is a little easier. Give me a moment. Okay, so to make up for giving you such a difficult special triangle application right away, I'm going to give you the special right triangle. 30 degrees goes here. This will be 3 on my hypotenuse. Since this is a 90, 30, 60 degree triangle, I know based upon my knowledge of it, across from my 30-degree angle is 1. Across from my 60-degree angle is my root 3. And my hypotenuse has a value of 2. So, You could totally think of it as, what do I have to divide by 3 to get 2? But one easier tactic would, oh, I guess this is X and Y. One easier tactic is, I actually can go, and I would suggest you go from the hypotenuse to the side length opposite to 30 degrees, since it's literally the value of the side length opposite to 30 degrees is literally in a 60, 30 degree, 90 degree special triangle. The side length opposite to 30 degrees is literally half of the hypotenuse. So 3 divided by 2, which I want to keep in exact values. So I'm going to keep it as 3 over 2. And once you figured out the side length opposite to 30 degrees, the side length opposite to the 60 degrees is simply made by multiplying the side length opposite to 30 degrees by root 3. So I multiply these together. What do I get? Please keep it in exact form. And I get 3 root 3 over 2. So that's one way to apply your special triangles knowledge. Then I have homework. Yeah. And please fill out the exit ticket, which is on Google Classroom. Oh, doesn't matter. They're both MCR. Please fill out the exit ticket on this announcement. Thank you. Hope, and I will see you Wednesday.